Earth is not a cradle. Earth is a target. The romantic idea of life, gently seeded across the galaxy by patient cosmic gardeners, falls apart the moment you look at the actual mechanism. A planet getting hit hard enough to throw its own biosphere into orbit. What travels between stars is not a gift, it is shrapnel. Rocks blasted off dying worlds, carrying whatever happened to be living in their cracks, drifting for tens of millions of years before colliding with something else. If this is real, then every world in every system is downstream of every other world's catastrophes. And the strange chemistry we keep finding on Titan suddenly stops looking like a local miracle. Picture the moment of ejection. An asteroid strikes a living world at 15 kilometers per second. Most of the surface vaporizes, but near the edge of the impact zone, certain fragments are flung upward faster than escape velocity while remaining, against all intuition, relatively cool. Simulations from researchers at Princeton and the Max Planck Institute suggest that a thin shell of material survives this launch, with its interior temperatures barely rising above what a desert afternoon already provides. Inside those fragments, in pores and fractures, microbial communities ride the shockwave out of the atmosphere. Then they wait. Vacuum, cosmic radiation, temperatures a few degrees above absolute zero. We know certain bacterial spores survive these conditions for millions of years in laboratory analogues. We have recovered viable organisms from Earth rocks that spent decades on the exterior of the International Space Station. The biology is durable in a way that genuinely should not be possible. So the lifeboat exists. The question is how far it can drift before the passengers stop being passengers and become something closer to fossils with ambitions. Run the numbers and the picture turns uncomfortable. A fragment ejected from Earth at typical impact velocities will, given enough time, sample most of the inner solar system. Given much more time, tens of millions of years, a small fraction will be slingshotted out entirely, drifting into interstellar space at roughly the speed of a passing comet. The galaxy is patient. Stars wander past each other on timescales that make this kind of crossing statistically inevitable. A 2018 paper in the monthly notices of the Royal Astronomical Society estimated that during the Sun's earliest, denser stellar neighborhood, the probability of biological material exchanging between systems was not small. It was, in their phrasing, near unity. Read that again. Near unity, which means the default state of the galaxy is not isolation, it is contamination. Every catastrophe on every inhabited world is a sneeze across the void. And somewhere in that drifting cloud of biological shrapnel, some fragments fall. Not onto Earth, but onto colder, stranger places where the chemistry never quite finished what it started. When Huygens fell through Titan's amber haze in January 2005, it returned data nobody knew how to categorize. Lakes of liquid methane, a subsurface ocean of water, complex tholins raining down for billions of years, and tucked inside the atmospheric chemistry, signatures that, on Earth, would be considered metabolic. Hydrogen disappearing near the surface. Acetylene curiously absent where models say it should accumulate. Some theorists suggest a methane-based biology, alien in every chemical sense. Life that uses liquid hydrocarbons the way we use water. Others suggest something more uncomfortable. What if Titan is not a separate experiment? What if it is a landing site? A frozen petri dish where biological shrapnel from a warmer, older system arrived 1 billion years ago, found the wrong solvent and stalled, neither thriving nor disappearing, just persisting at a chemical whisper. We cannot distinguish between these possibilities yet. The signatures are too faint, the surface too inaccessible. Dragonfly arrives in 2034. It will not answer the question, it will only sharpen it. 66 million years ago, an object roughly 10 kilometers across struck the Yucatan. The Chicxulub impact ejected enough material that fragments of dinosaur-era Earth, soil, water, microbes were almost certainly thrown into orbit and beyond. Some of that material is still out there, and the traffic runs both ways. The 2013 Chelyabinsk meteor, the size of a small house, slipped through every detection system we had and exploded over a Russian morning with the energy of 30 Hiroshimas. We did not see it coming. We do not see most of them coming. If even 1 in a million carried a viable passenger from elsewhere, and the statistics permit considerably more than that. Earth's biosphere is not a closed system. It never was. The deepest branches of the tree of life, the ones whose biochemistry seems oddly mismatched to early Earth conditions, may not be native at all. They may be the descendants of something that arrived in a rock and which no one has identified the source of, long before anything here was watching. So the question is no longer whether life can travel between stars. The mechanism exists, the math allows it, the rocks are already in motion. The harder question is the one we cannot yet answer. When we finally crack open a Titan ice core, or sequence the strangest microbe in the deepest trench, will we be looking at a separate origin, or at our own distant relatives marooned on the wrong world? If this kind of question is the one you keep returning to, the channel is built around it.